So we're going to solve quadratic equations by factoring. Before I had given you the factors in note 63. Now what we're going to have to do is factor. So we've taught you 4 different ways of factoring. 1 is pulling out a GCF. 2 is perfect square trinomials. 3, difference of 2 squares. And 4 is regular trinomials. So on number 1 here, first of all, what we're going to do, if you notice, I have a line in front of the set of parentheses, which means we're going to pull out a GCF. So remember to always look at the smaller number right here, which is 2. Will 2 divide into the other 2 numbers, the 4 and the 8, without getting a fraction? Yes, it will. So you know that's the greatest common factor. So we're going to go through and divide everything by 2. Now then, remember with our exponents, with having a variable, it's your lowest amount of exponents, which would be x squared. So x squared, we're going to divide on every single one of these. All right, so 4 divided by 2 is 2. And then we can subtract our exponent. So 5 minus 2 is 3. Plus, these 2's cancel out. And 3 minus 2 is just an x. And then the variables will cancel out here. X squared divided by x squared. So that cancels out. Minus 8 divided by 2 is 4. And so there you have it. Let's look at problem number 2. This one is going to be a perfect square trinomial. Your first term and your last term are perfect squares. So we're going to have an x and an x. And since that's a plus, it tells you the signs are going to be the same. That tells you what they're both going to be. So this would be a plus, and then the square root of 81 is 9. And when you check it by doing the FOIL method, the outside is 9x, the inside is 9x, which adds up to the middle term of 18x. Now then, since we have the same thing, we can simplify it even more. So this would be x plus 9 quantity squared. Number 3, this one is the difference of 2 perfect squares. So I already have it set up for you, being a plus and a minus. And the square root of 9 is 3. So this will be 3x and 3x. And then the square root of 49 is 7. So it doesn't have a middle term because the outside would give us a negative 21x. The inside would give us a positive 21x, which would cancel out. Okay, so this is an example of number 1 is pulling out a GCF. Number 2 is a perfect square trinomial. Number 3 is the difference of 2 squares. And number 4 is just going to be a regular trinomial because I know that the first term and the last term are perfect squares. But when you check it by doing outside inside, so for instance, if we did x minus 4 and another x minus 4, that would be a perfect square trinomial, we think. However, when you test it by doing the outside and inside terms, it gives you negative 4x and negative 4x, which is negative 8x. So this is not a perfect square trinomial. This is going to be a regular. So since this is a plus, it tells you they're going to be the same. That tells you what they're both going to be. So we're going to do an x minus and an x minus. We need factors of 16 that they're, when we add them, since the signs are the same, will give us 10. So that would be this combination right there between the 2 and the 8. It doesn't matter whether you put 2 first or 8 first. So there you go. So 1, 2, 3, and 4 were the 4 ways that we talked about up here. Now then, number 5. This you could actually do by using the regular trinomial. So what you could do is this. You could just do a trial and error. Factors of 2, your leading coefficient would be 2x and x. Since that's a minus, it tells you they're going to be different, so minus plus. And then you need factors of 3 that will give you 5. So let's see, that would be, we need a 3 here and a 1 here, so that, we need to change the signs. Okay, so what we're going to do is erase this. So this will be a plus and this will be a minus. So that'd be a negative 6x and a positive 1x, which is negative 5x in the middle, and then 1 times negative 3 is negative 3. So you could do that by trial and error, just by using the regular trinomial method. However, if you don't want the trial and error, you can use the bottoms up method, which is what you had learned a few lessons ago. So what we do is we multiply. This is your A and your C. So we have x squared minus 5x minus 6. And then we're going to factor that. So this would be x and x. And since that's a minus 6, the signs are going to be different. So minus plus. Factors of 6 that will give you 5. So that's going to be 6 and 1. And then, let's see, that's 1x, negative 6x, negative 5. And then we divide everything by the leading coefficient of 2. So that's going to give us x minus 3. And then 1/2 does not reduce to whole number, so we do the bottoms up. So that 2 is going to come in front of the x, so it'd be 2x plus 1, which is what we came up with up here when we did just a trial and error. So it's up to you which way you want to figure those out. But definitely when the leading coefficient and the last coefficient is composite, which means they have other factors other than one of it in itself, that AC bottoms up method would probably be a little bit quicker. All right. So now what we're going to do, letter C is solving. So when the factors are equal to 0, the x values represent the x-intercepts on the graph of a parabola. So we've done this before. So what we're going to do is set each equation or each parenthesis equal to 0. So just like here in the example, x minus 5 equals 0. So then you add 5 to both sides, and so x is 5. X plus 2 equals 0. Subtract 2 from both sides, you get x is negative 2. So for practice here, we're going to go x minus 2 equals 0. And then x plus 4 equals 0. And that's just a one-step equation. So you're going to add 2. So x equals 2. And then subtract 4. So x equals negative 4. And again, it does not matter which order you put your numbers in. These are just x values. It is not an ordered pair. So it just means that if we were to put the x minus 2 and x plus 4 into graph and graph this parabola, the parabola would, it would look something like this. And let's see, maybe I should have drawn the XY axis first. I could do that. So we got 1, 2, 3, 4, 1, 2. And so then it would go through at negative 4 and up through at 2. So it would look something like that. I'm not going to get into the vertex right now, but anyways, it would probably go a little bit lower, actually, more like that. So that's what your parabola would look like. Let's look at problem 2. So we have negative 3x equals 0. So negative 3x equals 0. Divide both sides by negative 3. And x is equal to 0. Here we have 2x plus 5. Now, if you want to save a little bit of time, you could go ahead and move that 5 over and make it a negative 5, and then divide both sides by 2. So that would actually be negative 2.5. So just as a little reminder, when we solve quadratic equations by factoring, we need to know, remind ourselves of the verbiage. So the x-intercepts are also known as the zeros of the function, the roots, and the solutions. So what are the x-intercepts over here? It's at -1 and 1, 2, 3. A few other things that we need to know is that the axis of symmetry, it goes right down through the vertex. So that's the axis of symmetry. And we've got our y-intercept, our two x-intercepts. So that's pretty much all you need to know about the parabola. All right, so let's go back to all these factors match the solution. So remember, they need to be opposite. So if you have x minus 1 and you set that equal to 0, your x is going to end up being a positive 1. And then your other x would be a -3. So this is completely opposite of what we need. Here we have x plus 1 equals 0. So we subtract 1. So we're going to get a -1. And then x minus 3 equals 0. So we're going to get x is equal to a positive 3, which is what we need. So this is what our factors will look like. They are opposite, or the x-intercepts will be opposite of what you see inside the parentheses. And this would be a positive 3 and a -3, which is not what we want. All right, so let's go ahead and look on the back side. So what we have to do extra today is we have to factor our area. And I mean area as in if this were the area of a rectangle. We have to find the length and the width. So let's take a look at problem 1. Solve each equation for its zeros, solutions, roots, x-intercepts. All that means the same thing. Sometimes you must factor first before solving each equation. So remember, we need factors of 6 that add up to 7. So we've got 1 times 6 and 2 times 3. So the factors would be 1 and 6. And since that's a plus, they're going to be the same. That tells you what they're both going to be. So it'll be x plus 1 and x plus 6. Then we set each one equal to 0. So x plus 1 equals 0. Subtract 1, so x is a -1. And then x plus 6 equals 0. Subtract 6. They're just the opposite of what you see. So that'll be a -6. All right, let's take a look at number 2. And we've got, that's a plus sign. It tells you they're going to be the same. That tells you what they're both going to be. So it'll be x and x. Both of these are going to be minus. Factors of 16 that add up to 8, which will be 4. So when we set each of these equal to 0, they're going to be the same thing. X minus 4 equals 0. We add 4 to both sides. So x will be equal to 4. So if it crosses the x-axis at 4, that will also be your vertex. Okay? So if you have 1, 2, 3, 4, right there is where it crosses. That's going to be your vertex. So your parabola will look like that. All right, let's take a look at problem 3. This is going to be where we factor out a GCF. So we look at the smallest number, which is 3. Will 3 go into 6 without getting a fraction? Yes. And then your smallest amount of x's, which is just an x. So we're going to have 3x parentheses. Now, to figure out what you have left over, we're going to divide each term by 3x. So the 3's cancel out there, you get x plus. The x's cancel out there, you get a 2. You set each one equal to 0, so 3x equals 0, and x plus 2 equals 0. So this one you just divide by 3, so you get a 0. This one you're going to subtract 2, so you get a -2. All right, number 4. This is going to be the difference of two squares if you haven't recognized it already, because the first and last term are perfect squares, and you have the difference, which is a minus sign. So this will be a plus 6 and an a minus 6. You set each one equal to 0. A plus 6 equals 0. Subtract 6, so you get a -6. And then a minus 6 equals 0. You add 6 to both sides, so you get a positive 6 there. All right, let's take a look at problem 5 and 6. Find the zeros of the function. Okay, so I can't factor anything out of all 3 terms. And I've noticed that the The last term, the 30, that is a composite number. So I think I'm going to go ahead and try the bottoms up method. So that's going to be c squared minus 19c, and then I multiply 3 times 30 and get 90. So this will be plus 90. Then I'm going to factor that. Since that's a plus, it tells you they're going to be the same. That tells you what they're both going to be. So it'll be a c minus, and then we need factors of 90 that add up to 19. Well, that's, thank goodness, that's fairly easy, 9 and 10. And then we divide. So we're going to go through and divide each one by the original leading coefficient, which is 3. So now we have, I'm just going to put these over here. So we're going to have c minus 3, and then this will be your bottoms up, because 10 divided by 3, it will give you a fraction. So it'll be 3c minus 10. Now we have to set each one of these factors equal to 0. So remember, they're just going to be the opposites. So if you do c minus 3 equals 0, we add 3 to both sides. So you're going to get c is a positive 3. So we can go through here and eliminate answer choice A and answer choice B. And then we have 3c minus 10 equals 0. So what we're going to do is go 3c, and I'm going to go ahead and put that negative 10 over to the other side and make it a positive 10, and then divide by 3. So that'll be 10 thirds, which will be this one. And remember, it doesn't matter which order they're in. These are x-intercepts. It's not an ordered pair. Number 6, given the area of a rectangle is to be x squared plus 14x plus 24 square inches, which of the following represent a length of the rectangle? Oh, all we're going to do is factor this. Since that's a plus, tells you they're going to be the same. That tells you what they're both going to be. And 24 is not a perfect square, so we have to think factors of 24 that add up to 14. So we've got 1 and 24, 2 and 12, right there, 2 and 12. So that would be the length and the width. So we have an x plus 2, and that would be it. All right, I hope this was a fairly easy lesson for you. Thanks. Bye.